I'm Gayatri, working as assistant professor in EC department at SNS College of Technology. Today I'm going to describe about the topic dielectric strength and dielectric constant, which is studied in EMF subject in the unit 2, electrostatic field and conductors. Before going to the discussion, we have recall about the topic what we have discussed previous. Before going to discuss about the dielectric strength and constant, we have to recall about the electric potential. The electric potential is nothing but it is a total work done. It is carried out from moving the one object to another object to the total charges present in that. The unit of electric potential, which is volt, and it is defined in scalar quantity, and the potential will be based only on the position when it is traveling from one point to another, not it is based on path. And coming to the topic for discussion, which is today I'm going to discuss about the introduction part of dielectric and how the electric field will be used in dielectric material and dielectric constant and the significance of dielectric constant and dielectric strength. At last we can describe about the comparison between dielectric strength and constant and the application. And the empathy part about the dielectric material, which is it is nothing but it is an insulating material, and which is does not allow any number of free electrons to be flowing in that particular material. Mostly the conductor which will allow the free flow of electrons in the materials, and dielectric will not allow the material to be passed through. When the dielectric material is placed in a electric field, it become polarized. For example, when we are using the rubber material or glass material or mica material, it will be get polarized, the material will be get polarized, and the dielectric material will be most used in a capacitance part and also as a inductance part and insulation part. And coming to the defined part of dielectric, we from the discussion we came to know about the dielectric properties, and keeping that property, the dielectric will be used in electric field application. When the dielectric material it is placed in external electric field, the charges will be rearranged, that the charges will be polarized, and in case of this electric field, the polarization occurs. The internal electric field reduces, so that the internal electric field, which can be related with the help of E, and it is E equal to epsilon naught divided by epsilon r, and dielectric weakness, which is applied to the electric field material. And coming to the empathy part or defined part of the polarization in dielectric, the dielectric types, which is electronic polarization, ionic polarization, orientation polarization, space charge polarization, and mostly the polarization will be depends only on the position and not upon the path polarization. And the electronic polarization, which will be occurs due to the displacement of holes and electrons, and ionic polarization, which will be occurred in the crystal lattice. And coming to the dielectric constant, which is nothing but it is the ability of material to store that particular energy, and it is also known as relative permittivity and denoted by epsilon r. The epsilon r, which is equal to epsilon by epsilon naught. The epsilon naught, which is a constant, which is a permittivity, and it has a value of 8.854 into 10 power minus 12, and it is dimensionless. Coming to the dielectric constant significance, which will be extended with the help of polarization, and the polarization will the concept which will be applied in the capacitance, and capacitance, which is nothing but charges divided by total electric potential. And when the capacitance dielectric constant increases, the capacitance also increases. With the help of this we can narrate the example. C is equal to epsilon or epsilon naught A divided by D, where A is a cross sectional area and D is a diameter of that particular material. And the it is used in the dielectric strength also. Dielectric strength, which is defined as the maximum dielectric field the dielectric can stand, and beyond this dielectric strength the material will be breakdown. That point is called dielectric breakdown. Dielectric strength, which is equal to breakdown voltage divided by thickness, and how it is illustrated. And dielectric, coming to the dielectric applications, it is used in the dielectric constant as well as dielectric strength, and it is used in substrate material, and it is microwave essential and PCB material design, and in the transformers this dielectric is mostly used. And let summarize this topic. Today we have discussed about the dielectric material and property, and what is potential and what is polarization, and the dielectric constant, where we are using dielectric constant and dielectric strength, and dielectric breakdown where it is used, and at last we have discussed about the application part. These are the references I have taken for this particular dielectric and polarization topic. Thank you.